I want to try to find f prime of x, a function which will give us the slope of the tangent line to this graph at any point where it is differentiable. F prime of x equals, just write down the definition, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. If we're focusing on a particular value of x, this is the slope of the secant line extending from x to x plus delta x. So this equals the limit as delta x approaches 0 of, well, here goes, 1 over the square root of x plus delta x minus 1 over the square root of x all over delta x. Now immediately we have a complex fraction. We have fractions in the numerator, no fractions in the denominator, but that's enough to make it a complex fraction. I would like to write this rather than the difference of these fractions over delta x. We know that dividing by delta x is equivalent to multiplying by what? So if we multiply by 1 over delta x, that's going to be equivalent to dividing by delta x. So before I do anything with those radicals, I'm going to rewrite it like that. It's going to be 1 over delta x times 1 over the square root of x plus delta x minus 1 over the square root of x. Now, there are other ways I might have tried to deal with that complex fraction, but I think this will work as well as anything. Difference of the fractions. I'm thinking get a common denominator. It won't immediately help us, but it will give us a difference of two radicals in the numerator. And then we've dealt with limits in the past where we have a difference of two radicals, multiplying numerator and denominator by the conjugate, somehow get the expressions out from underneath the radicals where we can combine them, and they can help us divide out common factors. I think it will help if we do this. So it's not immediately going to help, but it's going to lead to something that will help. So let's subtract the fractions. The limit as delta x approaches 0 of 1 over delta x times, okay, our common denominator is the product of the denominators, since they ostensibly do not have any factors in common. So just multiply the denominators together. We ask ourselves, this denominator, square root of x plus delta x, can be multiplied by what to equal the LCD? And then we answer ourselves, the square root of x. And the square root of x times 1 is the square root of x. So the square root of x can be multiplied by what to equal the LCD? Yeah, the other one there. So when we multiply that by -1, we get minus the square root of x plus delta x. So we still have delta x in the denominator, and at the moment there still doesn't seem to be a great deal of hope of getting a factor of delta x in the numerator, but there is. There is. If I could copy and paste, well, I can copy and paste it, but I don't know if I feel like it, so I'm just going to copy it like this. What I want to do is multiply the numerator and denominator by the conjugate of that radical expression in the numerator, square root of x plus square root of x plus delta x over square root of x plus square root of x plus delta x, and hope something good comes of it. 1 over delta x times square root of x minus square root of x plus delta x over square root of x plus delta x square root of x, and then the conjugate, square root of x plus square root of x plus delta x over the square root of x plus the square root of x plus delta x. Good things will happen in the numerator. They better. This doesn't look like it's nearly as elegant as the previous one involving the cubic. When we multiply those radicals in the numerator, we get cancellation take place. The square root of x times the square root of x is going to give us x, and then minus, careful with the parentheses, when we multiply the negative square root of x plus delta x by the square root of x plus delta x, these two right here. Of course, the radical sign vanishes, and it's going to be minus that quantity. So the quantity, since we're subtracting it, needs to be enclosed in parentheses. In the denominator, we've just got what we've got. Nothing really changes except we have a product. Big set of parentheses around the square root of x plus the square root of x plus delta x. Is there hope now of obtaining a factor of delta x in the numerator? I feel like I need to copy a great deal just to make that happen. So much has to be copied just to distribute a negative sign across parentheses. X minus delta x all over this. Whoops. Just about had that up underneath the radical. And then if we cancel the x and the minus x, we will then have a factor of delta x in the numerator. So I feel like just erasing them. Because you could probably look at this numerator and get negative delta x from that numerator. Can you get there? Yeah, stare it down. You can get a minus delta x out of that. There we go. The delta x and that delta x, now we end up with a negative 1 in the numerator. When we scratch that delta x out, negative delta x divided by delta x equals negative 1. So negative 1 is a factor of the numerator. So we have now the limit as delta x approaches 0 of negative 1 over the square root of x plus delta x times the square root of x times that quantity, square root of x plus the square root of x plus delta x. Finally, we can evaluate this by direct substitution. Substitute 0 for delta x in each of the places where we see delta x, and delta x is no longer a factor of the denominator, so it's no longer driving the denominator towards 0. So it's negative 1 over the square root of x plus 0 times the square root of x times the square root of x plus the square root of x plus 0. How many more steps? Negative 1 over the square root of x times the square root of x times the quantity square root of x plus the square root of x. Now we multiply the square root of x by the square root of x. I mean, x, in order to be in the domain of this function, is going to need to be greater than 0. Yeah, for sure. Even 0 itself is not allowed because it's got to be in the denominator. So definitely it's got to be greater than 0. So when we multiply the square root of x by the square root of x, we would get x, so no fears of that, times 2 of those. So if we can find a spot for it, put a box for the final answer here, f prime of x equals negative 1, or simply the negative of 1 over 2 times x. I left off the x. Good goodness. 2x times the square root of x. That's the expression for the derivative of this function. And I believe it has the same domain as the function. X has to be positive, and for this one, certainly x also has to be positive.